Okay, so now that we've created this update function, we need to create the show function. So what it doesn't really matter if you're updating the position of this data point if you're not even showing this position, like showing this object. So we're gonna create a function called this.show equals function. So it's gonna be a function that shows where this position is or where this object is, because no matter if it's moving or not, if we can't see it, then it doesn't really matter. So we're gonna say fill 255 comma, just say 255, that's white. We're gonna say no stroke. That's just a function in P5js. I'm not really gonna explain it. Ellipse. This dot pause dot x. Okay, this is where the scale comes in. Times scale, comma this dot pause dot y times this dot scale, and 5 comma 5. So what does this whole line mean? So pretty much what we're doing is we're showing an ellipse, but it's actually a circle because it has the width and the height are equal, so it actually becomes a circle. The position of this ellipse. So if you remember what we talked about while we were talking about in the previous. I'm hoping that I'll make it a previous video, but in the previous video we're talking about how we only want to map it between -5 and 5. Well, technically, if you map something between -5 and 5, it would be between here and here. So we have to scale that up so that the simulation, because we don't just want a small little simulation right here. We want a simulation that covers the whole screen. So pretty much we're going to scale this position up. And that's pretty much what the scale does. Yeah, and we're just making the ellipse white. And we don't want it to have a border. That's pretty much what that means. Okay. So yeah, we're pretty much done with the data point object. Now we just have to do a couple more things with the equation object and we're good. So the next thing we have to do with the equation object is we have to update all the data points that this equation object is the steward of, that it controls. So we're gonna say this.update equal function. And pretty much what we're going to do is we're just going to say for var I equal to 0, I smaller than a number of data points, I plus plus, and we're just going to say this dot data points at I dot update. So pretty much we're just updating all the data points that this function, that this equation is the steward of or is control of. Okay, and we're going to do the same thing with show. We're just going to change a couple of words. Show. Okay. Lastly, we're going to create one more function for this equation object. So the last function we're going to create is going to be called this.doneTraveling. This.doneTraveling equal function. And this is going to return a Boolean value based on if all the objects that this equation has control over are done traveling. Or okay, so the way that I did this is if one of them are done traveling, because for some reason it was kind of being a little bit weird if all of them, to check if all of them are done traveling. So if one of them are done traveling, then the probability of all of them being done traveling is very, very high. So we're just gonna do for var I equal to 0. I smaller than number of data points, I plus plus, and we're just gonna say if this dot data points at I is traveling. So this boolean, this expression says so is traveling return if it is traveling, it returns true. If it's not traveling, it returns false. So if it's not traveling, which is what we're trying to figure out, so we're pretty much saying if you're not traveling, then pretty much it says if you're not traveling, which returns a true statement, then do this. So what are we going to do? We're going to return true. And then If none of these points are done traveling, we're just going to return false after we're done with this equation function. So that's pretty much it. So we're going to save that. And now we're going to go to the simulation and actually start drawing the simulation. So let's just call this a variable called sin xms, which stands for sin x Maclaurin series. Well, you can name it whatever you want, but I just thought that that's a descriptive name. So the first thing we're going to do is after we made this variable, we're going to put a equation object inside of it equals new equation. So we want to map out the Maclaurin series from -5 to 5. We want to graph this Maclaurin series from -5 to 5. We want it to have about 300 data points in it. And let's make the travel speed, the number of steps each data point should take before it gets to his destination is about 200. That should be good. Then we go sin xms dot initialize data points. Okay, that initializes all the data points. Sin xms dot next term. This function kind of starts everything off. I think I missed one thing in next term now thinking about it. So I missed a really important part of next term. We got to add 1. We have to add 1 to n so it actually becomes the next term. Yeah. So make sure you guys do that in the function next term outside of the for loop. Okay. Yeah, so that should be good. Okay. So the next thing we're gonna do is we're just gonna say sin xms dot update. So this updates all the data points that this equation object is responsible for, and then we're gonna show all the data points that this equation object is responsible for, which is 300. That's the number of data points. And then we're going to have a Boolean statement which says sin xms dot done traveling. So if the data point in this equation are done traveling, then we have to go to the next term, meaning we've gotten to our destination. Please give us the next term so we can travel to the next destination. So dot next term. So we run that function. And yeah, so that should work. So let's save that. Let's go over here. Okay, so we have something wrong. Maybe some kind of spelling error or... Yeah, this is... Did I not spell this right? Initialize. It's a long name, so not the best speller either. Let's see if it changes. Let's look carefully. Yep, it changed. I wrote it wrong. Starting x is not defined at equation initialize JS type. Starting. Did I spell this one wrong too? Oh, I spelled starting x. Starting x. Starting x. What now? Cannot read property y of undefined equation dot next term. Okay. Wait, what is it? Maclaurin Series object dot JS 21. This dot data points. Oh, this should be this dot data points at a certain c at the index c dot pos dot y. Yep, that makes sense. I had a lot of mistakes in there.